some of you may have known as Fortius1 and had made GeoCommons and GeoIQ. That was recently acquired by a small Redmond-based GIS company that some of you may be familiar with. So what I'd like to do is to hand this over to Sean, and start looking at one of the core issues that we have in integrating the information coming from crowds into U.S. government operations and into authoritative data sets, and that's data quality. Sean?
Great. Thanks, John, and appreciate the opportunity to have such a distinguished group of panelists here to work with, and such a great audience to talk to. So I really wanted to dive into this issue of quality with crowdsourcing data.
It's connected.
Excellent. We have Mookie. Very good. And really wanted
to do them yesterday. I got the total opposite of this. I got their picture. Up to the room.
You know what?
Yep.
Yeah.
Just 1 second. We're still working on it. You can begin.
And so I think especially we have such a great disparate group of panelists that come at this from different perspectives. And I think one of really the core issues when you talk about quality control and just quality issues with crowdsourcing data is the type of crowdsourcing that you're doing. I think we have a tendency to kind of lump a lot of things under crowdsourcing, but we'll see, especially with the various projects that folks work with, that there's a lot of disparity in how these things work, and quality for them can be very different definitions and different meanings. You know, on one hand, you have things that are almost completely unstructured, like Twitter, where it's almost what Crooks and some others at George Mason have called ambient geographic information, where folks are doing something without the intention of necessarily contributing information to a cause or an issue or an event, but in the process there's geographic information associated with it, and that gets pushed up as almost exhaust that comes off of the data that other folks can tap into and repurpose. Then you have kind of organic communities that have sprung up, like OpenStreetMap, where they're not necessarily contributing to a cause or an existing project. The project is an end and means in and of itself to create a global map of roads and places across the world. And then you have things like the Christmas Eve project, where there's an existing scientific project that's already out there, where folks volunteer to help out a group of authoritative members or scientists that are pushing a project forward. Or even Yoshihide, where a text message or a text number gets set up that folks are instructed to, if you need this, text into this number. If you want to provide information, text into this number. So we really have a wide variety of disparate kind of crowdsourcing projects. And then how you address quality across these can be anything ranging from doing statistical sampling and mechanical learning to try to understand what the structures of these things look like from a statistical perspective, to feeding things like confidence intervals and error and so forth, to very on the ground of getting people to confirm things that are physically there, looking at it, and then tying this into traditional metadata structures that we see in things like GIS and other scientific and computational approaches. But kind of with that as an introduction, I thought it'd be really useful to have each of the panelists go through and for a couple of minutes introduce themselves and talk a little bit about the kind of crowdsourcing projects that they've worked on, and kind of their perspective on what that looks like. And then open it up to questions as we get an understanding of each person's perspective on the kind of crowdsourcing they've been involved with, the approaches to quality, and how we work with that, and really let the audience here in the crowd online ask us questions about it. But
if I could just do a quick test with the video conference.
Sure. Okay.
Can you guys hear us? Okay.
Okay.
Are we good? We're good to go. Okay.
Okay, great. Hi, everybody. So I'm Robert Monroe. I work for an organization called eBon. I run that out of San Francisco, and we do language processing at scale. So someone spoke of the use case where a tweet would come in, you'd see that it was related, you'd automatically reply to that person, based on some sort of low-level artificial intelligence. That's the kind of technology that we create. So my background is in commercial information management and commercial crowdsourcing. So I was doing this up until the late 90s. And at the same time, I was moonlighting in post-conflict development in West Africa. These were two very separate vocations for me. And now, obviously, crowdsourcing has become tied to post-conflict development, to disaster response in general. So these are the two strands that I bring together. Hopefully, I won't need to know much about my post-conflict development here with work with the U.S. government. One thing I would like to talk about straight away is which kind of social media we're looking at, because everybody today has spoken only about Twitter so far. I don't believe I've heard anybody talk about Facebook or LinkedIn or the other social media platforms that people might use, most of which are much bigger than Twitter themselves. I think this is especially true for citizens as censors. So for citizens as censors, Twitter is probably one of the worst possible platforms that you could be looking at, because you have the least information about the credibility of a given person making a report. So for example, on Facebook, let's say there is some disaster at a given location, it's very easy for you to go and find out people who are already at that location. You can see the local hospitals and schools in that area. They will often have their own pages on Facebook, for example. And then you can look at a person's social network and then determine, well, is this someone who is already connected to this community? And that takes care of some, but not all, of the security concerns you might have as well of someone infiltrating to spread what might be deliberately malicious data. And so this is something we actually used in the response to the earthquake in Haiti in 2010. So I coordinated a volunteer effort called Mission 4636, where it was predominantly Haitians translated in geolocation information in real time. And verification was a big part of this. And for the most part, we simply called people back. We didn't have a big problem with people misreporting information. And people reporting by SMS, we would call those numbers back for anything that looked like it was actionable intelligence. Beyond that, when we had to create situation reports about given locations, especially outside of Port-au-Prince.
Message saying that your mic is muted. Could you unmute your mic, please?
I'm being talked over here.
London.
So again, it was very easy to find via Facebook, but not via Twitter, the right kind of communities to connect with. So there were Facebook pages dedicated to hospitals at given locations, and the people who were members of the groups or active on those pages were people that had a close connection to this given location. So it was fairly easy to immediately find and engage the right citizen censors with that local knowledge. But I don't think we would have had as much success if we tried to do that on Twitter only.
London, your microphone is muted at the moment.
I'm being talked over here. So again,
unmute your mic so we can
I'm going to talk over this. I hope you can hear me clear enough while we get this sorted out. So again, as I stressed before, it was predominantly a Haitian effort. I think there's been a lot of focus on international actors and reportedly new technologies. This was not actually the case. I would love to take credit on behalf of a lot of the international community, and they certainly deserve recognition for everything they did, but this was 90% Haitian. The majority of people who processed information were Haitian. They were the ones who really reached out and made all those connections locally to process that information. And among the 10%, which was by international actors, the majority of people who were either working in management or supporting the technology were from Silicon Valley. So I think this is at odds with some of the media and even some of the reports that I've heard earlier today about this being new technologies and international actors. It simply wasn't the case. This was people with a very strong social tie to the disaster itself, working on what were, for the most part, very established commercial technologies. So I think I'm coming to the end of 5 minutes here, so I'll a couple of points I'd like to touch on perhaps a little bit more in the discussion phase. So one, you've heard that Red Cross report referenced, where it said so many people would be willing to report by social media. I haven't seen the one today. The old one was terrible. It was not the kind of survey that would have passed peer review. So I think the way they frame the question would be that something along the lines of, would you include social media among the avenues by which you express that you're in an emergency situation, which is essentially akin to saying, would you talk about it more broadly if you're already on social media? And then I think the figures also included, would you use social media if other avenues weren't available to you, which again, I think is akin to would you talk about it? So the actual figures that the majority of people would reach out on social media and expect a response, I think are unreliable. I think it's perfectly fine to think that the real numbers are lower, and you don't have to meet that expectation as a response agency. I also want to talk more about the statistical side of things and how commercial crowdsourcing really is a statistical approach to information processing, where you have multiple sources of information and you cross-verify that. But I might leave that more for the discussion because I'm sure some other people have some thoughts as well.
Well, great. Thanks, Rob. Let's go over to Mookie so we can hopefully sort out some of the technical back chatter. Mookie, thanks.
Mookie, can you hear us? So part of the technical issue is that they're saying that our mic is muted, but we can hear you fine.
They can't hear us.
You still can't hear.
He's got a phone right there. Can we ring him?
Well, we'll move on to Kate then, and hopefully we'll be able to circle back to Mookie. Wait.
1 second,
good?
we're going to try
Okay.
one thing.
This is kind of down and dirty, but
I don't care.
let's see if it works. Hi, can you hear us now at the Wilson Center?
Yes, now we can hear you. Can you hear us? Okay.
Please go ahead, Mookie. Sorry.
Okay. So I do have feedback, so it will be good if when I'm speaking you switch off, you mute your side until I finish, and then we'll switch it back on. So if you can put the images, it will be good, but I hope that the 5 minutes that I'll now give will give you an idea even without the images. The research on quality of crowdsourcing information actually started in 2008, and it's now maturing really, really fast. The natural start was to start looking at existing information sources, and it's quite amazing the range of sources that have been tested, starting from national mapping agencies in the UK and in France, commercial data set like Navtec and TeleAtlas, and surely other testing that never been published because they're done by commercial companies. And consistently you see high level of positional attribute accuracy and the usual operation of Linus loss. So the more people you have per aerial unit, you get better quality, and also self-correcting mechanism, including experiments in deliberately vandalizing data sets and discovering that within 10 days that everything is being sorted, and currently research into social networking. Now, the area of disaster response started with the 2010 Haiti, as John just discussed it. And if you can put the first slide that I sent over, if it is possible, then you would see that the comparison between the three data sets, the UN data set, the Google data set, and the OpenStreetMap data set. And part of the reason that this analysis was done was because the argument between Google and OpenStreetMap about who got a bigger data set and who can do it faster. But there are several interesting things there. First of all, I used for it an algorithm that was developed originally for data sets with a comparison with the Ordnance Survey data, and it worked quite well, and the analysis for the level of being good enough was done really quickly. And secondly, that it was very popular. This website was hit, the page and the image was hit at least 1,000 times during January 2010. Now, the point in more detail, if you have the ability to see the second image somewhere, That's an image from London with analysis that was done by the PhD student Thomas Kukletus. So just it will be published within the next 2 weeks, and you can download the PhD, where you compare it to the top quality data from the Ordnance Survey. So we're talking here about 1 to 1250 scale resolution, and you can see that in central London you get really good data. Actually, the way I describe it is that if I'm in central London and someone needs to reach me if I got, God forbid, a heart attack, I actually would prefer that they will use OpenStreetMap, especially if they are coming on a bike or some other mode of transport, because that will be better than the Ordnance Survey. Now, if it will happen to me in the suburbs, that won't be as good, and you can see actually how we deteriorate further out as you go. The third slide shows you the area of Liverpool, where things starting to be interesting. So regardless of where things are exactly are, and you'll see it in the next slide, what you can see is that the positional accuracy is actually quite good. We are talking about things that are up to 10 meters or so. And there is the difference between the different area. But if we look now at the fourth slide, where you also see the index of deprivation of Liverpool, and you see the different area, you see the relationship between, and in this type of data set, we see consistently connection between positional accuracy, attribute accuracy, and completeness. So you see the deterioration according to the socioeconomic status. And similar things have been shown also in New Orleans when the data was checked from that. So that's the first warning about this stuff, because we have here the cacophony of the strongest, where they can shout louder and they might divert resources. So kind of to finalize about where we can go with it is that there are different algorithms that are capable of taking into account the specific characteristic of and provide valuable information from it. We can develop clever conflation that overcome legal and copyright issue. I don't think that that's a huge problem, actually. But there are core differences between the necessity in crisis situation to work in fairly military style operation, because you need to operate according to exercise and work each bit of the operation need to operate according to what they've exercised, and this cacophony that is coming from the crowd. And what we need to remember that instead of trying to think about something that is duplication of effort, for example, I've seen in one of the documents arguing that it's a bad thing. Actually, with crowdsourced information, it's a good thing, because if we are thinking about algorithms that will try to compare multiple sources of crowdsourced data, we do want the duplication in order to get it. Where we were used to ask for lack of duplication is when we had scarce resource. When we have multiple people using different social networks and starting to use different platforms, you do want the duplication, because they will use different things according to their knowledge and abilities, and also to the current thing in the social network. After all, not everyone will hear about everything, and then you can develop algorithms to combine the information. So those are kind of the first thoughts about where we should think about in terms of data quality. So if you can, yeah.
Well, thanks, Mookie. Appreciate it. Move on to Kate, please.
Thank you, and I won't need my slides if you.
Okay, we have them here if you need
No,
them.
no,
Good.
thank you. My name is Kate Starboard. I'm an assistant professor at the University of Washington. I just finished my dissertation working with Project EPIC at University of Colorado, working with Laisha Palin, who will speak later in this conference. My research has looked at very particularly the digital volunteer communities, crowdsourcing from the inside, a lot of it. So I've been looking at how people have been acting in different ways to help organize information. And I liked how Sean brought up that there's these different meanings of crowdsourcing, but I've looked at so many different kinds, and I've been looking at it from the inside out. So I've seen digital volunteer communities that come together after disaster using social media tools. We've seen it in Haiti, where it was mostly remote volunteers. We've seen it after the Joplin tornado and many, many other events. I've looked at the crisis mapping communities. I've been involved with Humanity Road, which is a digital volunteer community that moves from event to event to event and continues to train new volunteers. And with them, I've also worked with the Standby Task Force and other groups. So I've really spent a lot of time as a participant observer within these communities to understand who these people are, what their motivations are, why they do the work, how they do the work, how they come together. And it's very much been an insider's view. I've also looked at some of the early VOS. So we have some VOS people here, but virtual operations support teams. So I've seen some of their early work as they've come together to try to figure out what it means to do virtual response or virtual information processing. So my way into this activity was through the Tweak the Tweet project. A lot of times we get labeled as we do the Tweak the Tweet. Well, that's just one thing we've done. But to describe that project, it was initially an idea where we asked people to use certain kinds of language in their tweets to make them easily processed. And so we've talked about people going to a certain website to fill out a form to send information. Well, we were asking people to put information in a certain format, but they could broadcast it over Twitter. So basically piggybacking on the infrastructure of Twitter, also allowing people to report within their social networks, but at the same time upload information in a way that we could easily process it without doing a lot of algorithmic or machine processing. It turned out, as we initially deployed it, it wasn't really good for people to use from the ground or people to use for their own needs. It's very hard to learn how to put information in the way we'd asked them to put it. We called it a micro-syntax. But it was adopted by digital volunteers. So it's adopted by digital volunteer communities, so people that wanted to help out were seeing this information, and they were using this innovation we put out there to help process information. And so we deployed that for more than 30 events between 2010 and 2012 to allow people in the crowd to help process information during disaster. Eventually, we built up the infrastructure with maps, with spreadsheets to help show where that information would be available and to try to give it to people so they could tap in to this information processing by the crowd. So, so when I think of this, and we've talked about different kinds of crowdsourcing, I've seen a great diversity of crowdsourcing. And then I've seen this also trend for a lot of people to think about crowdsourcing as one particular kind of thing. In my research area, a lot of people have begun to think of it as microtasking, like Mechanical Turk, where we give people these little tasks and they all do them and they give us the answer back. We also, here we've talked about crowdsourcing as just citizen reporting, so that information going into the system for the first time. But there's a lot of different layers to crowdsourcing. And so I think of it sort of as this layered system where we've got all these people adding information through different social media tools. And then we can have some automatic tools that are processing that. And then we can have layers of people or volunteers at different levels processing that in different ways. And so we've got these sort of tools that come in different ways to help us make sense of this. And we see information activity like amplification. We see verifying work. We're seeing structuring work in multiple ways. We're seeing people synthesize information into resources at different levels. But these are all different kinds of activities, and they're done by different kinds of communities. So as we start thinking about how this information can be processed, it's interesting to think of it as different components and try to understand the different communities that are doing different kinds of activities along the way, and also where machine learning and algorithmic learning can tap into that, both as creating tools for volunteers and tools for crowdsourcing, and also creating tools that learn through what people are doing in the crowd. So learn through how people are retweeting to help figure out how to find people on the ground. Learn through how people are social networking to figure out what the reputation of the user is. And so there's all these sort of these feedback loops between volunteers and the algorithmic solutions that I think are really interesting. And as we talk about quality of data, that's really going to be an interesting question, is how to get the crowds to work together with what we have coming from the technology side. And I think, well, I want to comment a little bit. I don't know if I'll have a chance on the use of Twitter. I think a lot of our research has looked at Twitter for a couple of different reasons. One is, as in the moment, you can use a lot of different tools. As a researcher, we don't have access to a lot of the things that happened on Facebook in the same kind of way that we have access to what happens on Twitter, and we can pull it out. I think as emergency responders, a lot of tweets are public, so you can access that information in a different way, whereas Facebook pages are often closed down, although there is a lot of public information out there as well. But we use Twitter in two ways. One is just as the data, but another is as pointers back to other places on the internet. So a lot of tweets contain information that points us back to Facebook pages, that points us back to conversations that we're having, so that it can be kind of used as a map to get back to the kinds of interactions that were happening on social media. And finally, we talk about reputation. Well, I think reputation on Twitter, though someone just has a handle and it doesn't have often tie to their personal reputation, people care about their reputations over time. And we can easily go back to their history and access different things. So there's a lot of opportunity for tools that can assess reputation, assess where their networks are, assess whether they're astroturfing and they're kind of a fake account, assess whether they have a long history. So there are ways to access reputation on the Twitter platform, but it's certainly not the only platform out there. And I'm really interested in seeing, I mean, Instagram instantly changed the face of what I do, because for some reason in their default settings, so much has geographic information on it, and all of a sudden we have thousands and thousands of tweets that before we had pictures that didn't have GPS information, maybe a few did, and now it's tenfold the amount of tweets I have with photographs that are geotagged because of Instagram. So it's interesting to think about how social media changes are going to happen and affect what we do in good ways and bad over time. And I'll pass this on.
Then please, thank you.
I'm Len Ursery with the U.S. Geological Survey. I am the director for the Center of Excellence for Geospatial Information Science, CGIS. CGIS actually is the research arm of the national map of the U.S. Geological Survey. And one of our questions right now in terms of research is, how do we take advantage of all the crowdsourced and VGI information for the national map and make it a part of our authoritative databases? And then the second question that follows on to that is, where does this take mapping in the future? What does it really mean for the national map and those of us that do authoritative mapping in the future with all of these other resources that are all of a sudden available? Well, the USGS has used volunteer data prior to the digital age. In our 7.5-minute mapping program, users found errors on the maps. They would either find missing or incorrect names, misplaced features. They'd send annotated corrections to USGS, and we'd incorporate those in the next printing of the maps or the next revision. In the 1990s, we formed the Earth Science Corps, which used a thing called Adopt a Quad program. This again was annotating paper maps with revision information and sending it to USGS. It later became the National Map Corps with a web-based interface with a focus on locating structures. We'd have users actually find the actual GPS locations of structures and send that to us. Unfortunately, in a lot of cases, when they were locating structures, they'd give us either the GPS location at the street or at the entrance to the structure, whereas the way we record information is we record the center of the building. So there was a lot of work for us internally to process that type of information, and we were getting more information than we could really handle with the workforce that we had to apply to that. So we essentially suspended that program. Well, with the influx of all of the information from Volunteer Geographic Information, we decided to reevaluate that. We structured a workshop in 2010 on VGI. We had many different participants from a lot of various VGI programs of different types. Some of the major issues that were identified at that workshop, the number one was data accuracy. But there are other things, types of tasks that are suited, how do you motivate volunteers, how do you integrate the VGI data with traditional information, what is the cost-benefit analysis of this kind of stuff. So there were a lot of questions that came out of that. The results from the USGS side was that we actually structured some research projects to try to evaluate these things. We began a project called the OSM Collaborative Mapping Prototype, the OpenStreetMap. And what we're trying to do is to assess how we could use the OpenStreetMap software stack to actually enter data into the USGS national map. We tested with one of our partners in Kansas, a couple of counties, with the Data Access and Support Center for the state of Kansas, and loaded the data in. Primarily what we're looking at was transportation data, and the effort was on editing interchanges and dual carriageways, which were not in the Kansas data to begin with. This project basically, phase one, showed that VGI usage within our authoritative data structures was possible. The phase 2 of that project was structures data collection, and that was done with students from the University of Colorado at Denver and the University of Denver. We customized the OpenStreetMap Potlatch editor for use in this project. We had downloaded essentially the structured information that we had, and then we had the volunteers to increase, update that, edit it, and add new information. 1,214 structures points were added to the USGS databases for several quads in the Denver area. The analysis showed about 92% of the points collected by the students met our accuracy standards. In the analysis, there were several things that were learned. We need to simplify the editing and user interface. We need to stress volunteers, the importance of adding structures that are missing, and emphasize the importance of conforming to editorial guidelines for formatting names and addresses of structures. Again, the accuracies on this, 89% met National Map accuracy standards that went through volunteer edit and collection. 91% actually met National Map accuracy standards that went through the volunteer peer review process. So again, there's some lessons learned. We had inconsistent participation. It was difficult to get students to follow a specific timeline. We tried to use a message board for communicating with students. They preferred email directly to the people in USGS to get responses. And the tests may have been too difficult and too complex. Well, phase 3 of this project is actually to expand it to the entire state of Colorado and allow any citizen to contribute their structures data. Does the process scale to large areas and large numbers of volunteers? So these are some of the kinds of experiences that we've had with volunteer geographic information and trying to incorporate it into the authoritative data that we distribute with the national map and the U.S. Topo products. I'll turn to another aspect of this information. We have a number of people working on this. We recently brought on board Sophia Liu, who is a postdoc student, one of our Mendenhall postdocs, and she's working with one of our CGIS scientists, Barbara Poor, and also with Paul Earle, who's in the hazards program. Sophie and the people she's working with have really developed an article, and it comes back to what Kay talked about, that crowdsourced information is of many different types. And they developed essentially a typology of 10 different types of crowdsourced media, and this is all documented, and the article that's going to be is under review for publication that will actually distribute this information. So there are a number of things like that that are ongoing. And I guess with that, I'll stop at this point.
Yeah, thanks, Len. Appreciate it. So we wanted to open up the conversation now with folks online and here in the room. And I think for the panelists, if we can keep our responses to a minute or two, so we allow as many perspectives on each question as possible, that'd be great. So we go ahead and kick it off. Any questions in the room first? Yes.
Is there any study showing what kind of information is best suited for crowdsourcing and what kind of information is not?
I can address that a little bit from a USGS perspective. We looked at the kinds of tasks that were appropriate to get from volunteers in our VGI projects. I pointed to a couple of examples. We started with transportation, but we found that was a little bit difficult for them to provide us information that we could work with. So we went to structures, a simpler type of geographic feature that's represented as points. So there's a little bit of that from the VGI perspective. From the broader crowdsourcing perspective, I would look to other people for the answers.
I don't know how exactly to answer that question. I've seen crowdsourcing communities are good at certain kinds of things and processing certain kinds of information after disaster events. It's often, I don't know if you know what a folksonomy is. It's where they develop their own things that they're seeing a lot of, and they're able to process those things. And they don't always match up to what responders need. I was just talking to Chris Erickson, who does fire response, and what the crowd is good at reporting, of what the crowd is good at processing, isn't necessarily what the responders need. that maybe not what the kind of information they need, or that maybe that's not the kind of information that they're used to dealing with. So there's some mismatch there. I think one area of interest in the future will be if we can understand what emergency responders might need, and they can kind of talk about what information and in what ways. There may be ways to develop platforms or develop volunteer structures where the volunteers are meeting those needs, but we haven't connected those very well yet, I don't think. As a person who's been studying this, it's not always what the crowd is doing and what responders need is not always connected.
Yeah, I can talk more to the processing side of things, and I thank Kate for earlier distinguishing citizen reporting from the processing of information. I think that's a really important distinction for crowdsourcing. In a commercial context, citizen reporting is not typically called crowdsourcing. That's actually something that's fairly unique to this community, just for possible confusion in terminology. So on the processing side of things, translation has been found to be really successful as a crowdsourced task, both in commercial and humanitarian crowdsourced contexts. So I think it's probably fair to say that there's been more crowdsourced translation than there has been mapping. Certainly there's 10 times as much translation as mapping in the response to Haiti. The same was true for the response to Japan as well. There was an organization that did real-time voice translation called Interpretation, called Babelverse, and they opened up their platform for free to have Japanese-English translation during the response there. It just doesn't get as much publicity as mapping. As for processing, it depends somewhat on your workforce as well. So this is something I've looked into quite a bit. So in terms of mapping in the response to Haiti, we completed a study comparing people with local knowledge to international volunteers. So the average, or the median rather, amount of time for someone with local knowledge about the geography of Haiti to geolocate an unstructured message was about 4 minutes, 4.5 minutes. The median time for an international worker, so this was the group at Tufts that John Crowley mentioned this morning, was a little over 4 hours. And the accuracy was much lower as well. Plus they had to do this on translated information. They couldn't obviously read this in the original Creole. So yeah, that is one example where crowdsourcing can be successful, but it requires a crowd to have that vital local knowledge. Looking at the more statistical side of things, I've looked at data in the response to the 2010 floods in Pakistan. So I think, as a lot of people know, that was actually a much bigger logistical effort than the response to the earthquake in Haiti, but again with less resources. And we were comparing a system called Pack Report, which I helped run with George Shamalis, who's in this room somewhere and speaking about security tomorrow. And we used a commercial crowdsourcing platform, as in Haiti, called Crowdflower, where we gave the same task to multiple people. And then we're able to build up an idea of individual workers' reliability by how much they agreed with other people that they're working in parallel, and weight the responses based on our aggregate understanding of how reliable they were. And so we found that by giving the same geolocation task to 2 people, and then aggregating the distance between those 2 points that they selected, weighted according to their reliability, that actually produced more accurate results than someone who was very well trained. So this was evidence that you would want to put this kind of task out, geolocation, to as many people as possible, and use statistics to combine that, rather than have your trained group of people standing by or always ready to geolocate. Had another example. Oh yeah, so cost effectiveness as well. So most crowdsourcing is paid. It's actually quite rare for there to be volunteer crowdsourcing. Again, there's somewhat of a bias in response. So looking at Libya Crisis Map, which was an OCHA-run initiative in the response to the uprising in Libya, if they had have paid for this to have been done by commercial workers on a platform with good statistics rather than volunteers, it would have cost only about $800. OCHA committed people full-time for more than a month to this, and towards the end of that weren't that happy with the reliability of volunteers because there was burnout, and actually had 3 people working on 8-hour rotations in-house. OCHA probably spent several $1,000s to save themselves $800 by taking on volunteers rather than doing it through a paid commercial outlet. And I realize there's institutional barriers to pay crowdsourced workers rather than volunteers. But I think that is something that organizations need to keep in mind when you only need to process, say, a few thousand data points.
Thanks, Rob. Mookie?
Yeah, I'll use some examples from citizen science. So the point about the type of information that can be get, it keeps surprising me about what people can do, from classifying more galaxies than any professional astronomer around to all kind of other things that are happening. So in terms of the type of information, actually I would argue that there is almost no limit to what you can get, apart from if you need to be on the ground at a specific time. That's the kind of local information that you need to really rely on people that are there at a certain time with the communication and the skill. But also to remember that within the crowd, you got this participation inequality, which means that you got some people that are very active, some people that are in the middle and a long tail, and each one of them got different characteristics, and they will have different behavior and different information. So there isn't such a thing as just crowd. It's actually a lot of different groups and different characteristics, and you need to figure out what exactly you're talking and what kind of information that you need. The more complex it is, the smaller the potential crowd that you've got.
Thanks. Sorry, is it a question?
Yeah, so, can you all hear me? No, honey?
So my name is Gisli Olofsson, Emergency Response Director of NetOpe. First, just I think one of the key things we need to figure out is what Kate just mentioned, which is how do we actually tell the crowd, tell the volunteer community, tell people what data is it that we need to make better decisions about how we respond. But I wanted to ask the panel, we constantly hear when you talk about crowdsourcing or citizen reports, this thing about quality and, can we trust it? Are we going to get lots of false reports? Has anybody actually taken a look and compared, what we're getting through the crowdsourcing and the citizen reports versus what we're getting through the traditional channels of 911 and other things? Because we're getting the false reports there too. As a first responder, on the ground in Haiti, we were sent to different places to look for people buried under the rubble, and there was no one there. And those reports were coming in through non-social media channels. Are we painting too much of a danger there when it comes to false reports in this channel versus any other channel?
Thanks. Anybody like to lead off with an answer to that?
Yeah, I've seen no strong evidence that information reported through social media is inherently more unreliable than through traditional channels. It doesn't mean it doesn't exist, and I think also that there's a large amount of variation depending on that channel. So in some types of social media, I think there is more of an incentive for someone to at least exaggerate their position rather than deliberately introduce false information. And not to criticize Twitter again, but it's actually one of the worst places for this because you're competing with so many other voices on Twitter, and your interlocutor is not clear to you. There is less incentive for you to stick to what is the exact truth. So you're more likely to be sensational, and you're taking in information from sources other than what you're observing, and it's not always clear. So in the case of Haiti, as you mentioned, the most reported event on Twitter was the need to do search and rescue operations at the Caribbean market after it had already been cleared as a place for search and rescue. So there were false rumors going around that there still needed to be search and rescue operations there. And it wasn't that this was one tweet that got retweeted. This was information that was consumed a number of ways and then tweeted in at least a dozen different ways, which were then retweeted. So it was a real problem in that regard. If you were just looking at what was the most reported event, you would find something that didn't exist. Whereas that didn't happen through SMS channels. There was something about reporting directly and immediately being able to like call back and verify with people that meant that that didn't happen. So I think that it's very heterogeneous.
Just to let you know, I led the team at the Caribbean Market.
Oh, I didn't realize that. Okay.
And I can tell you that, yes, we did search the building. No, we did not clear the building. Yes, we sent teams there the following days to follow up on those things. Yes, they did find people.
Okay, so this
So-
report on Twitter was 2 weeks after the
2
earthquake.
weeks is, yeah, there was nothing 2 weeks. What happened was, it was immediately in day 2 and 3 and 4 where people were being found there.
Okay.
There was also some problem where the dates on the Ushahidi platform got reset, and people were seeing things and they thought they were live and they weren't, and they reintroduced them into the system, and then those echoed and they went out of control. There were also things that happened about 2.5 weeks into that event. They had some late rescues, some really sensational ones that were on TV. Well, a lot of people who still had relatives that hadn't been found re-reported their relative missing, said, oh, I just heard from her, she's still alive, can you go look? So there was a lot of different information, and like you said earlier, it's about exaggeration. Well, it was about, it's exaggeration, it might have been misinformation, but they were desperate and they were trying to manipulate the system in different ways to get responders to come back. So there was a lot of things having to do with it. That being said, that report is all over, and it keeps going way after it's valid, and it begins to be attacked by social media. And we've talked about how social media will self-correct, it'll attack. The problem is there's a lag there. There's a lag on that attack. There's a lag in how fast we're going to be able to see the crowd attack bad information. There was a study in the Chile earthquake that afterwards someone traced rumors, and they saw that the crowd did attack rumors. The only problem is if you're acting on those rumors and they're live, you may not see the crowd attacking it till an hour later. So there's that problem. And then also on the Twitter platform, something that causes things to get worse is as information gets amplified and spread, it loses the connection to the original time it was sent. And so people don't have a way to know that. And so for that reason, you're right, Twitter is particularly bad, is that information will continue to spread long after it's relevant.
Anything you want to add, Mookie?
No, not in this time, not on that issue.
Lynn? Yes.
Hi, I'm Lori Van Leuven. I'll be a panelist later today. I appreciate Kate's description of crowdsourcing as being layered. And when we're a lot of times in discussions about crowdsourced data, we're talking about individual data that may occur in a close proximity to each other. But I'm also curious about whether you've seen or looked at the behaviors of crowdsourced data that layers on top of a data point, such as conversations, echoes, clarifications, disputes, things that are actually attached to one particular data point that might help us, capture the veracity of that report rather than trying to process over and over again so many individual pieces.
Do you spend a lot of time there? I know, we've been talking about this for a long time, is to use the crowd's reaction to information to find what the message is. We have a paper about that from the Egypt protests. I'm not sure this was a great way to tell people to look at it, but you can actually tell who was on the ground in many ways just by looking at how the crowd reacted to the information by the people on the ground. They tended to be more retweeted in specific types of ways. And so we think there's a lot of opportunity for looking at the information of the interaction around information to find the signal. So to look at the noise to find the signal.
Are there any tools, any processing work being done in that area?
I believe people are looking at how to do that. I don't know which tools incorporate methods like that, but I imagine there are some out there.
That kind of information processing, so event coreference detection and trying to identify conflicting reports, that isn't really beyond a research stage anywhere. There is nothing that people can yet deploy and use. For that kind of scenario, I think there's a lot to be gained for simply contacting people directly for clarification rather than trying to make sense out of conflicting reports.
Yeah, we've seen a little bit of where that workflow is reversed, where a stream of information from Twitter or another source is then bidirectionally confirmed by folks on the ground. So streaming to a mobile device, these are the social media or other crowdsourcing activities having near to me, and having somebody like an urban search and rescue folk confirm and validate that, with a mobile device, and then that flowing back and verifying that within the greater systems. I know some of the things that MGA and FEMA have been experimenting with.
And if I can add just to that, it's a different type of issue that when we've done the conflation, the same student that I showed the combination between the OpenStreetMap and the Ordnance Survey data, the last exercise that we've done is actually trying to see if we can mesh Google MapMaker and OSM data for Haiti, and to see what you get from that. And actually, what we've seen is that you can get some ID, and you can have an automated tool that allow you fairly quickly to conflate the two sources and see where they agree and where they disagree. And that, for example, can feed into things like the humanitarian OpenStreetMap team tasking, so you know where there are holes. Or, for example, the issue that I showed on socioeconomic issue. If you have an area where you got a silent that comes because there is a population that's suffering from a digital divide and doesn't tweet, you will also can notice that and have systems in place to recognize it. So it's not just conflicting and other things. Don't just notice where you got the information, also notice where you don't have.
I just want to take a quick step of if Leah or Andrew, if you guys had any questions flagged from email or Twitter. So back to the audience. Yes, on the left.
Hello, my name is Luis Bermudez from the Open Geospatial Consortium. We are right now running a pilot where we do every year, and we are now trying to get crowdsourced data, try to match it with traditional data that is available from Web Feature Services, the National Map, NGA, TDS data. The problem that we have is trying to find the best way to qualify Twitter data or any other crowdsourced data. So my question is, you have talked about reputation in Twitter, you have talked about quality 90% because you are trying to see if it is the same as the data that you already have. But is there any qualitative way, method, tool that you can say, well, if we have all these tweets from this person or this community, we can put a number and we say, this is the trust level, or this is 80% quality, etc.
Sure, and if this will be the last question, we got about 2 minutes left, so if folks would like to give a brief response, that'd be great.
Actually, just briefly, I don't think the number of reporters is a very good method for determining the veracity of a given event.
Well, there are some ways if you have information on who's supplying the data, and this is actually being used by some of the companies, and we're using some of it in the volunteer data that we're gathering, and that is you develop a trust in certain people that have a history of working with that and supplying information. So there's a provenance or lineage of that information does give you some faith in that, well, this is better than this over here because it came from people that we know that have provided good information before, and they develop that reputation. So there is that line of research of provenance of the information that's ongoing.
Yeah, we've played around a little bit with doing like a streaming chi-square by geography to also get at some of the issues that Mookie talked about, so you can kind of see what's your confidence level, and then bringing in things like reputation, so it's not just, as Rob was saying, just a count of the number of people, but how many, what's the reputation of the folks within that area, and particularly how many duplicate entries are you getting from folks, and begin to normalize the data that way, and have that dynamically updating, because these things are so fluid, and we're used to very static kind of confidence intervals. But I think are we time? Okay. Yeah, apologies for not getting to everybody, but thank you so much to the panel and all the great questions from the audience.
So what I'd like to do is to take a look at how we can take some of these issues on quality and begin to implement them in terms of how a government agency can begin to look at catalyzing this type of data collection and what design principles need to be put in place, and then how can we take this data and put it in authoritative data sets that are used to drive decision making. And with that, I'd like to thank this panel, and we're going to bring up the next panel. Nigel, the floor is yours.